record. All right, so in part one, when we're using the color strips.
Yes.
Okay. So here for part B, oops, sorry, I forgot to mute my phone. All right, so we want to show 1/6 and 1/3. We want dark green to be a whole. So I'm just going to copy this into my drawing pad. So the dark green is the whole there, and we want to show 1/6 plus 1/3. So again, these are in order. So the dark green one is 6 of these unit. In the toys I have on campus, that one is actually a cube. So this rectangular box that's green is made up of 6 of the white ones. So the white would be 1/6. So let's write that down. If the dark green is one whole, then the white is 1/6 of that whole. And what else do we need to do? 1/3. And so the previous question kind of answers that. If the dark green is a whole, 3 of those red pieces make that dark green, so the red is 1/3. So if we want to illustrate 1/6 plus 1/3, then we would take a white piece. So this can be my version of a, oops, I need to change color. This is going to be my version of the white piece up there. And then that's 1/6. 1/3, come on colors, please work with me. There we go. 1/3 would be twice as wide. So that's the red piece there. And when we put those together and compare it to the dark green as a whole, best to draw that. So that should be 1, 2, 3, 4, 5, 6 units wide, my dark green piece. The black one sits right here. The white one sits right there. Oh, sorry, I thought I turned that off. Hang on a sec, I'm gonna have to check this. Right back. Right, sorry about that. I thought it might have been a family emergency since they know I'm in class, but it was not. And I lost my magic pen. Okay, so where was I? All right, so I'm putting this white piece here, and then the red piece I'll place on top here. So that would just sit right next to this. So when we take 1/6 and combine it with 1/3, then I can see in this green block, it looks like we've covered 1/2, and I can confirm that by picking up the light green piece. And I don't have enough green shades in my tools here to show that, but those two together make the light green, which is 1/2. I was looking for something like that. So this would be, again, part 1B of that activity. That sufficiently answers the question.
Thank you.
Yeah. Other questions? Homework, activity, And welcome, Mason. I hadn't seen you earlier. I'm glad you're here. Okay, so last class, the big ideas were what does fraction addition mean, and what toys can I use to model it? What pictures can I use to model it? And we used a few different things. We used the color rods here, we used the pattern blocks, and we draw our own rectangular regions to demonstrate fractions. And then we did subtraction, and I used the comparison model, but the takeaway model works, I think, equally well. Although I like the comparison model slightly better. But there's two things that matter. One, what does addition mean, or what does the subtraction mean? And then what does a fraction mean? So we're just going to take those ideas and extend them over to multiplication next. So multiplication of fractions. What does multiply mean? Well, we had a bunch of different ways to talk about multiplication way back when we were doing whole numbers. And so some of the top ones was it's repeated addition. Another idea related to repeated addition was the idea of groups of. So example of the groups of would be like, what does 2 times 3 mean? Well, it means we have 2 groups of 3. So we literally replace the multiplication symbol with the phrase groups of. And here's, one group of 3, here's the other group of 3, and there seem to be 6 things there. We also had the area model, the array model, oops, not another number 3, how about number 4? And these two are closely linked together. And then there was the Cartesian product, or the looking at choices, which I'm not going to do right here. So most of these work well with fractions, but not all the time. So we're just going to have to experiment a little bit. Like if I wanted to do, for example, 3 times 1/2, I could use that groups of idea to say I have 3 groups of 1/2, and if I know what 1/2 is, then I should be able to figure this out. And so using my square cakes idea, there's 1 group of 1/2. Here's another group of 1/2. And here's a 3rd group of 1/2. And when I put those all together, there's a couple ways to look at it. Putting 2 of them there, I certainly get 1 whole, but I have a little extra that's going to spill over into another cake pan. So one way to look at this is I have 1 1/2. Or you could just count and say, well, there's 1, 2, 3 halves. So that works pretty good. Repeated addition idea is similar. This would be 3 halves added. So that would be 1/2 plus 1/2 plus 1/2. And we know how to add fractions. These have a common denominator. 1 plus 1 plus 1 is 3. The denominator is 2. So the repeated addition works pretty good there. The groups of works pretty good there. If I try to look at this in terms of the area approach, I'm going to say that for the area, let's use a different color. Let's have a base of 3 and a height of 1/2. And so if I try to draw that out, let's say that's 1 high. So then that about there is about 1 wide. And I want to go 1, 2, 3 wide. And then for the height, I don't really want to go 1 high. I only want to go half of that. So right here would be my 1/2. And so then my area I'm drawing is this area right here. That is 1/2 tall by 3 wide. And if I just draw a couple of extra dividers, like where the whole numbers cross, and remember we did this earlier with bigger numbers, this is my answer, whatever that shaded region is. And again, that's 1, 2, 3 wide. And keep in mind what a hole looks like here. A hole in this case would be 1 by 1. So this square over here would be 1 hole. So I should make a note of that. And the answer is, well, there's 1/2, there's another half, there's a 1/3 half. So I can see here that the area is 3/2. Or I could regroup kind of like I did down here, right? So that's related. And I could show that the area is also equal to 1.5. So there's a couple of ways to look at it as a mixed number or an improper fraction. Which is better, the mixed number or the improper fraction?
Depends on how you want to use it, right?
Exactly, it depends, right? They're both great answers. If somebody looks at the 3/2 and says that's not reduced, I would imply, well, actually it is reduced because 3 and 2 have no common factors. To reduce means to divide a number out of the top and the bottom. 3/2 does not reduce. So it's a great answer. 1.5 is another great answer. So if I needed to do a calculation next, I like 3/2 better. If I was describing a distance or a length to somebody or like a cooking recipe, I like the 1.5 better. Depends on the context. So yeah, it could go either way. So we're going to play around with these ideas of groups of an area mostly. Repeated addition works most of the time too, so that's nice. And in a couple of contexts. So we'll be drawing some of our own pictures, and we'll also be playing with some toys. So I'm going to do another example like this, and then I'm going to split you guys into groups to try a practice example, and then we're going to take a look at the activity together. Just give me a sec, get set up here. All right, so we're going to use, so I'm in the previous activity. I'm going to jump to the new one, but first I need this link here. And let's get to the new activity, which should be right after this one. So we worked on that a little bit in class the other day. You just need to tidy it up and turn it in. So we're going to look at modeling multiplication here. And I'm going to do a slightly different first example than this one. I trust you guys can read through this one. So I'm just going to walk through a different one. And then I'm going to set you guys into groups to do part B here. Then we're going to regroup, talk about it a little more, and then draw some other pictures here. So what I want to do here is, let's see, I want 1/2 times 1/3 is what I'm going to model. And anytime you're doing modeling with fractions, you got to know what a whole is. And sometimes we change that. Sometimes a square is a whole. Sometimes a single one of these guys is a whole. Sometimes we've used 2 of those as a whole. So I got to be upfront about what does a whole mean. And let's trash that piece. I believe, what did I start here? We're going to do 2 hexagons as a whole. Okay, so I should have left that. All right, so just maybe I'll throw this off in the corner here and just put a note on it. Hexagons is stick that right there. So that's kind of like my key in the corner. So then I need to think about what is 1/2. Move that. Not yet. Okay, what does 1/2 times 1/3 means? And so I'm going to go with my first idea, which was groups of. So I'm going to write what is 1/2 groups of 1/3. Mark. Stick that underneath. So I need to write the question I'm trying to answer here. Okay, what is 1/2 groups of 1/3? Well, I can't find half of a group of 1/3 until I find 1/3. So my first step here, 1 to answer that question. What is 1/3 here? So let's see. Well, here is my hole there. And if one of them was a hole, that would be a third. So since 2 hexagons is a hole, then 2 of these is a third. So this blue shape I've just made with 2 rhombuses is called a chevron. So in this case, this chevron is 1/3 of the hole. If you're not convinced of that in the moment, let me make it so. So if I throw another 2 down here and just tweak them a little bit. So here what you should see is there's that chevron shape there. There's a yellow version of the chevron shape there, and then there's another blue version of that chevron. So I have 1, 2, 3 congruent chevrons here. Those out of the way. All right, so that's 1/3. Okay, so step 2. Now I have to find what is 1/2 of that. I don't know what half of that is. Well, I mean, I can pretty much look at this and say, well, like that one right there is half. So I'm going to answer that question underneath by putting another hole and saying, well, that piece right there is half of this third up there. And then finally, I can answer the question, what part of a hole do I have? I can say that 1/2 of 1/3 is, how many of those blue pieces make up this double hexagon hole? Anybody?
Six.
6 of them, yeah. So that 1/2 of the third is 1/6 of the whole. Exclamation point. Whoa. I mistyped. That should be a half right there. Let's move that here. Okay, so here's my sequence of events. I got to know what a hole is, so I got my little key there. The problem I have is what is half of a third? Okay, so I just rewrite what is 1/2 groups of a third. I'm using the groups of definition for multiplication. I can't find half a group of something until I know what that thing is. So I have to establish, okay, what is a third again? And so I figured out, okay, this shape right here is a third. Now I can find out what half of that is. Well, that's half of it right there. And what part of a whole is that? Well, that is, that 1/2 of a third is 1/6. Maybe I could be a little more clear there and say is 1/6 of. Questions on that example? Now, without these toys in front of me to demonstrate that, I could try drawing it on paper. And I don't know if you guys have tried drawing these hexagons. Some days it goes well for me, some days it does not. And my guess is most of you will have the same kind of problem drawing that out. So what I'd like to do next is have you guys give this a shot, annotating a page like this. And you can just type on it like I did, or you could try drawing on it with the scribbly tool, whatever works for you there. Get rid of that scribble. So to get this up, you could go to the resources page and find the pattern blocks. I am going to just grab that URL and stick it in the chat right now, which might get it there quicker for you. If I could find the chat, there it is. That is the pattern blocks page. If you want to go there, and let me make the groups here.